What is primary memory? What is RAM and ROM? All the devices have this, but many of us don't even know what are they. So, in this video, we're going to go over all these concepts. First of all, the primary memory is also known as the main storage of the device. It is the kind of memory that is accessed first and also the first type of storage before all the data and instructions are decoded and executed. For this reason, the primary memory is used mainly to run applications, run the operation system, and also the user interface. And finally, the primary memory is divided in two types, ROM and RAM. But as I said before, what is RAM and what is ROM? Well, first of all, RAM stands for Random Access Memory. It is the type of memory that is located mainly on the motherboard, is volatile, meaning it can be accessed at any time, or the information stored in this memory can be edited. On the other hand, ROM stands for read-only memory. It is very different from RAM since it is a permanent storage, it is essential to start a PC, and it is non-volatile, meaning that the information stored in the ROM cannot be edited.
But what is exactly the difference between RAM and ROM memory? Have in mind that RAM memory is the platform from which the multitasking capacity of the computer or device depends upon. Basically, to rephrase this, the RAM memory is the platform that will run the different programs at the same time on a computer. The RAM memory is also able to store data from these programs that are being run in real time on its databases. Nevertheless, this is not a guarantee that this information will be safely stored, since, as my partner mentioned in the previous slide, RAM memory is a volatile and temporary memory, which means that whenever the computer is turned off or the electricity flow is cut off, any data that is stored in here will be lost, for sure. So to illustrate this, please think of a public playground. In a public playground, several children and families are all going through the attractions and the different games, and they're having fun, and the place is crowded. However, when a storm arises a place like this, all the families will go away, leaving no trail of their presence on the park. This is pretty similar and pretty alike to what happens in a RAM. All the programs or attractions in the park are run at the same time because there's different children on each of the things the park offer. But whenever electricity is cut down or the computer is shut off, none of this will be stored and no trail of it will be left on the RAM. So how is this things that I explained from the RAM different from the ROM? Basically, the ROM is a safe place for information, is what enables all the users of electronic devices to store information permanently through time and regardless of if the device is turned on or off. So that's why I used these pictures of fresh concrete as an example, a daily life example that resembles the ROM. Why? Fresh concrete, as you can see in the picture of the hen, on the right of the hen, retains the footprints of the hen, just as the ROM retains information through time. And regardless on electrical flow, so that is why it is a very good example. However, fresh concrete does not, it takes very long to dry and it doesn't have much benefits rather than actually holding the footprints of the hen. Similarly, the ROM doesn't have much more benefits compared to the ROM, um, rather than retaining information permanently. So to wrap up this question, here in this table are presented some of the main differences between RAM and ROM. Um, a quick glance of it would be ROM is slower, it has less capacity, information here is not easily modified. Also, it's harder to access this information, and another important thing is that a ROM, the hardware of the ROM, is a small magnetic device, whereas the RAM is a longer green chip, and clearly the RAM is quicker, it has more capacity, documents are easily accessed here, and it stores files and individual or separate documents, while in the ROM there are stored programs and data that is permanent. Now let's see a different part of the memory of the computer, the cache memory. What is cache memory? Cache memory is a space of storage of frequently requested information um, for the CPU. So the cache memory is a place where information that is constantly required by the CPU is gathered. Information such as data, instructions that are always needed by the CPU. Without the cache memory, all this information would be spread on the different sources of the and locations of the main memory. The cache memory gathers all this information and speeds up this process and works synchronized with the CPU. Also, it's important to mention there are several cache memories in the CPU.
We know the definition of the cache memory, but what are the purpose of the cache memory? The first purpose is to store program instructions that are frequently re-referenced by software during operation. Fast access to these instructions increase the overall speed of the software program. And the second one is it also avoids the need to access the dynamic RAM to retrieve the same data repeatedly. We have some types of the cache memory. The first one is the cache memory in the RAM, and the second one is the cache memory in the L1 and in the L2. We're going to talk first about the cache memory in the RAM. There are two types, the dynamic RAM or the static RAM. The dynamic RAM is quicker and smaller in capacity, its slower main memory, has a simplex structure, using main memory offers reduced power consumption, the information is stored in the capacitor. While the static RAM is faster but more expensive, temporarily stores instructions and data so that the processor doesn't need to access the slower main memory. The slower main memory is the dynamic RAM, has a complex structure, are used in cache memory, requires constant power supply and consumes more power. The cache memory in the L1 is placed in the microprocessor itself, is faster and each code in the CPU has it. While the L2 is placed in the primary memory, slower and each code in the CPU has it.